All right, so today what we're talking about is creating loops that have loops already inside them. So basically we're nesting loops inside other loops, kind of like we did with the if statement. Remember with the if statement we were able to nest in another if statement on one of the sides? Just roughly, what would the flowchart look like for a nested loop? So it looks something like that. You have this external loop where you loop through this way. Well, you start here and then you go in here and you loop around for a while. Once this loop finishes, it fails, the condition fails, so it goes back up before the first one. So again, we've got inside of there, we have a loop nested inside another loop. Now remember the diamonds mean you're asking a question or it's like a condition. The boxes mean just process blocks. So we're going to see how we create a structure like this inside of Java. That's the goal today. But for the example, what they're doing is trying to create a triangle. The first time through the loop, you draw one set of square brackets. Second time through, so you can actually see as you go through the loop this triangle that grows. We create an outside loop that's going to loop through all the rows. Basically, n would be how many lines we want to print of the triangle. The triangle is only going to just get bigger as you go through this loop. So the question is, how many rows do you want? Well, that's where the value of n comes in. I is your counter, so we're counting from 1 to n, including n. And then actually to go through the columns in our triangle, we usually use the letter J. The idiom, or I guess the habit most programmers use is if they need an index, they call it I. If there's another loop inside of that one, you usually use J. And then if there's a loop inside that one, you use K. And you just keep going through the alphabet. Because all those indices don't really have to have a specific name. They're just to tell us what pass of a loop we're in. So for example then, here is the internal part of our loop where we're going through the columns. J's are columns from 1 to I, which is the number of rows we have. And based on the row number, it generates the pairs of square brackets. And I'll keep doing that until J is greater than I. Once J is greater than I, then it puts a line feed at the end of the line. That's what this is here. And then it goes back up to the top. Evidently R is a string. So let's look at it all together then. What does that look like in code? So here's our triangle class. It has a width. And then here's our loop. It's just called toString. So we're overriding the toString method of the triangle class. We start with an empty string. Here's our outside loop. The width comes in. The width is a private instance variable. So when we created the triangle, we said how wide we want the base of the triangle to be. That's when we want to stop. So we're going to that width. Here's the interior loop that we just saw. We're looping through all the columns in that specific row. So this is how you loop through the rows. This is how you loop through the columns in the rows. Okay? And then once we get to the end of that row, we put in a carriage return or a line feed. And that takes us to the next line. That's the same as doing a print line. And then it just returns R. R is a string, so we're returning that string. Then the question is, how do we actually run the program? Say we want to create a small triangle. We put in 3 as the width of the base of the triangle we're trying to create. And just say small.toString, and it will print itself, or create a string that has all the things it needs to display the triangle. And then we use that to send out to the print line. So it's kind of a nice little way to do it. You call toString in here. Whatever toString returns, which is a string, you pass that directly in the print line. So you're nesting this function call inside another one. So nesting happens all the time in programming. You can nest things inside a type of others. We've seen nesting in if statements, we've seen nesting in loops. Here we see nesting inside functions. This function returns a value. That value can then be used as a parameter into the next function. Okay. Here, if we want to see 15 in our triangle, put that in, and we'll see 15 rows where the base of the triangle grows until it reaches 15. The key here, though, is that doubly nested loop. So here's an example what the program looks like when it's run. The first one creates 3 rows, and the base of the triangle is 3. Here's 15 rows. The base of the triangle is 15. Now, you use nested loops all the time in programming, sorting, searching, those kind of things. Lots of times your data is in a kind of a grid, and you use nested loops to iterate through all the elements in that grid. Now, when we start Java2, just a show of hands, how many people are taking Java2 next term? 1, 2, anyone else? 3? Okay, so we'll continue on this discussion. In Chapter 7, we talk about arrays. And that's where we see those grids of data. Instead of just a single variable, we see multiple variables all put in an array up in the memory of the computer. So 3 rows of 4 would look like that. They don't show you the actual printing part, but you put the print in there, and then you put out another line. So it does each column in the first row, and then once j reaches 4, or actually increments to 5, it jumps out and it does the next thing. Here's the different. You have 4 rows of 3, but each one has 12 stars in it when it prints out. So typically the outside is considered the row counter, and the inside is considered the column counter. Here's some more examples. This is the one we just did, right? This one. Here's another one. This is kind of interesting. You say j, and then you have a percent sign. Does anyone remember what the percent sign represents? What operator? Remember the name of that? It's going to be on the final. Just want to make sure. It's one of the arithmetic operators, plus, minus, divide, times. There's a 5th one. It's called modulus, or mod. And basically that's the remainder operator. You take j and you divide it by 2, but instead of returning the quotient, you return the remainder. It's kind of like the remainder operator. So when j is even, the remainder will be 0, and when j is odd, the remainder will be 1. So the only 2 values you get out of that is 0 and 1. So if it's even, then it's going to print out a star. Otherwise, it's going to print out a minus. And so you see an alternating between the 2 patterns. I really like the modulus operator. You can do some pretty cool stuff with it. We used it, remember, in the leap year method to figure out it was evenly divisible by 100 or by 4. Right? We use the modulus operator for that. Here, if you want to do diagonals, it's a way to do that. Just by putting in a space in there, you kind of get this offset pattern. So with nested loops, you're given a lot of different opportunities to affect the output of your program. So how would you modify the nested loop so that it would print out a square instead of a triangle? Well, that means the width and the height are the same, right? In your loop, I think instead of using I, you would use width. Let's see what that looks like. Yeah. So in that interior loop, before it was I, but now you're saying the width is what we want to do with j. So it's not going to go from 1 to whatever I is, whatever row we're on. It's going to do 1 to the width that was passed into the triangle method. So you change that inner loop, and then you get a square of square brackets. What's the value of n after the following nested loops? Yeah, I'm surprised by the answer.